learning. Today, I'm going to start talking about chemical reactions. But before we get into that, we have to talk about one thing, the conservation law of mass. The conservation law of mass simply states matter cannot be created nor destroyed, but is only changed from one type of matter to another type of matter. In chemical reactions, basically what happens is, how you burn something, people think it just disappears, right? No, it actually goes into the air in the form of CO2 and water. And I'm going to give you a couple examples of chemical reactions today, but the point is that we're talking about the law of conservation of mass and demonstrating that through chemical reaction. And first demonstration that I have, we're going to be burning a candle, and I'm going to show you how there are the reactants of wax and oxygen get changed into water and CO2. Even if you cannot see them, it is happening. And the only thing that's happening is we're adding energy to a system of two different molecules, and the wax and O2 are being broken down, recombined into CO2 gas and H2O water in the air. And after that, I'll be doing another demonstration of something you might have done over the weekend. It was Easter, so keep that in mind. First, basically, we got a candle. A lighter to add some energy to the situation to get the chemical reaction started. Boom. We set that on fire. One of the ingredients for a fire or a candle is oxygen to keep a fire going. But we need to take one of those ingredients away. I'm going to try to keep for some reason the candle's not going very well. But in our demonstration here of the candle, we have a chemical reaction of the wax and oxygen being combined to form carbon dioxide and water. And then we're going to take one of the reactants away. We're going to take oxygen away by putting it underneath the cup. And as soon as all the oxygen is burned off, there will be no more reaction. So in a minute here, this will take a few seconds because it's a rather large cup. So the candle should be getting smaller and smaller and smaller as oxygen depletes in the thing. And all that left should be the smoke that's left in there. And I'll also be showing another demonstration today that we did over the weekend. I did a little egg coloring this weekend because it was Easter. I hope you guys did a little bit of egg coloring this weekend, got out there and did that. But I'll be showing you that next. Before I get into the nitty-gritty of that first demonstration of a chemical reaction with the candle burning, I wanted to show you the chemical formula of a candle burning and what's happening there. First, I have carbon and hydrogen, which is 25 carbons and hydrogens together in one big molecule that forms wax. And this is going to be our wax molecule. And then we're adding oxygen, 38 molecules of gas. Remember, our oxygen comes in pairs. And these are called our reactants, the beginning side of the equation. And products are what we get out of the chemical formula. So we're going to put that over here. These are our reactants on this side, the things that react together to get a product. First, I want you to notice, since we're talking about the role of conservation of mass, you notice that you have 25 carbons on both sides of the equation, 25 here and then 25 over here, and 52 hydrogens. You take 26 and multiply it by 2, that's 52 hydrogens, so 26 H2O molecules make up 52 hydrogens. And then you have O2 molecules, so you have 38 times 2, that's 76, I believe. So you have 50 over here, and then you have 26 over here in this molecule, so that's 76 oxygen molecules. So on each side of the equation, you have 25 carbons, and hydrogens you have 52, and then oxygens you have 76 oxygens. And you have this number of these molecules on this side of the equation, proving that when you burn a candle, the wax just doesn't disappear. It turns into carbon dioxide and water molecules. That's why when I lifted that cup up, you saw a little bit of steam, and the smoke was the carbon dioxide. And that's the two things you were seeing in the experiment. You were changing wax and oxygen into carbon dioxide and water. And that demonstrates the law of conservation of mass. I'm going to do one more demonstration that demonstrates the law of conservation of mass and also demonstrates balancing a formula like we did here. The next example I'm going to show you is one you might have done over the weekend. If you dyed eggs over the weekend, you did the next example I'm going to show you. As you guessed, in the second demonstration, we are dyeing eggs. I'm doing this with my little nephew and wife. They are dropping the pills into the combination of vinegar and water. The vinegar is dissolving the dye tablets, which adds to the acid, which is acetic acid in vinegar. Then when you add egg, which shell is composed of calcium carbonate, is added to the acetic acid, it will break down into carbon dioxide, which is what you see at the bubbles, and it will also add the dye from the acid to the calcium acetate, which binds to the dye in the acid, and that's how you get to the colored eggs. Demonstration, basically what you saw was acetic acid from hydrogen combining with the calcium carbonate on the eggshell, breaking that calcium down into calcium acetate, which is an acid which grabs the negative molecules from the dye, which is not expressed in this formula, but that's what dyes the egg. And then you have your other products, H2O, which is water, and carbon dioxide, which is what you saw in the reaction. You saw those bubbles, the carbon dioxide. In order to demonstrate the law of conservation of mass with this chemical reaction, we have to figure out how many atoms we have on each side of the equation. On this side of the equation, we have our reactants. And then on this side of the equation, we have our products. So we have calcium carbonate, which is our eggshell. And then we got the acid from the vinegar. And then what we have on this side is we have the acid, calcium acetate, which is the acidic shell, which grabbed the negative charge of the dye. And then you had water and CO2 as our products, carbon dioxide. Now we got to count the actual atoms to see if this equation is balanced. So to make sure that we're not disobeying the conservation law of mass. So on this side we have 1 calcium on the reactant side, 1 carbon, and then we have 3 oxygens, and then 2 hydrogens. And then on this side we have 1 calcium, 1 carbon, 3 oxygens, 1, 2, 3, and then 2 hydrogens. So we know that chemical equation is balanced, and it's a demonstration of how conservation law of mass is just molecules changing from one molecule to another type of molecules. In this case, it changed from calcium carbonate and acid hydrogen ion to calcium, water, and carbon dioxide, which the carbon dioxide is what you saw in the chemical reaction of the egg dyeing, proving our law of conservation of mass.
La la. Oh.